Welcome to the fecal coliform testing process. We're going to talk a little bit of background on this bacteria and then your responsibilities for your test. You no doubt remember that fecal coliform is a bacteria found in the intestines of warm-blooded mammals, birds and mammals. It gets into water when those animals defecate into the water, or if they defecate onto the land, it can wash into the water. You know about runoff, I'm sure. When the water is tested for this, the fecal coliform itself is not dangerous, but it can indicate the presence of other bacteria that are dangerous, bacteria that can cause devastating diseases. If you've ever heard about beach closures in Chicago or elsewhere in the world, they are testing the water for this bacteria. And if they determine the levels are too high, they will in fact close the beach. Sanitation plants test for this bacteria as well, and we are testing it in our river water. When you are at your testing site, your only job actually at the river is going to be to help out the benthic macroinvertebrate people when they collect their creatures. We've gone over this in class. We're just giving you a reminder. You will also collect your water sample, and you will make sure with your teachers that all your equipment has been sterilized, so when you come back into the lab it's all ready to go and you're ready for your testing. Hi, we're back in the lab now. We're going to show you now is the sterilization process of your lab table. In the background here, my able-bodied assistant is going to prepare himself to work safely by putting gloves and safety glasses on, as you will also. This kind of goes without saying, I'm sure you know. What he's going to do, Mr. Piskel, is take rubbing alcohol, wash his hands with it. What he's doing now is killing any other bacteria that might be in this environment. There's bacteria all over every place. I don't care how clean you think everything is. It's all over every surface we work with all day. So what he's going to do is simply pour alcohol on the table, get some paper towels, and thoroughly saturate the entire work area with alcohol. By doing this, any other bacteria that's in the area has been completely wiped out. The equipment we're using, the autoclave, the graduated cylinders and all the glassware that's been put in an autoclave, all the bacteria on that glassware has been killed. The bottle here, which I'm not touching since I'm not geared up yet, was also autoclaved, so there is almost no chance that there's anything else in that bottle except bacteria from the river. What we're going to do in a minute, once this is sterilized, is show you how to work as a team. There's probably going to be 4 of you. There's only 2 of us, but we'll show you how to work in a team of 4 so that you're getting this test done efficiently and effectively by having different jobs with different people in your group. So we'll show you that next. All right, now we're going to show you how to prepare the water samples to run your test, like we told you before. Mr. Piskel has brought all the equipment out from the autoclave. So what's been autoclaved is the pipette, the filtration device, and these graduated cylinders. This is what we're focusing on here. Here's our sample of river water. This is so concentrated with bacteria, if we tested this directly, it would be off the chart. So what we're going to do is put some of this in these various cylinders, and with each step we're going to make the concentration of river water less than it was before. And then when we test all those samples along with a control, we'll have a good range of data to look at, and we can tell which sample is the most useful by having different concentrations. So step 1, we're going to have our able-bodied assistant get us 99 mLs of deionized water. While he's doing that, I'll take our river sample. You get to use the cool high-tech pipette device, which I know you've practiced in class. You need to get 11 mLs of water out of here. So we're preparing like 110 mLs of water, 99 of deionized, 11 from the river. Now this capacity of this pipette is only 10, so we're going to have to run like 2 samples out of here. Thank you very much. So I'm going to fill this to 10. It's graduated like a cylinder. It's even more precise though. And you can control it with this thumb screw. There's exactly 10. Thank you again. He's doing an excellent job. If I add the water in here first, the river water, and then follow that with the deionized water coming in will do all the mixing for me. So you don't need to do any, you don't need to stir it up or shake it or turn it upside down or anything like that. So we're slowly. There's 10. Now I need one more. So what I want to do is go back into my river water sample, and it doesn't matter what you go up to now. You only need to add one. So just to make sure, I'm going to fill it to 5. Nice and carefully. And drop this down to 6, so I'll have 11. I got an extra drop there. Actually, I want to waste that down the drain. It's pretty harmless river water. You're actually probably going to be done with the sample. Don't throw it away. Don't put it down the drain yet, but just put it aside. We probably have all the river water we're going to need, and we'll explain that to you in a second. So thank you. If I mix this, like I said a moment ago, I've got 110 mLs of water. 10% of this is river water. The rest is deionized water. There's enough bacteria in here probably to give me a good result. You'll see colonies of bacteria growing out of here. Even though you can't see them, we know they're in there. Now we still have 2 more samples to use. What we're going to do now is a pretty simple thing. We need 99 mLs of deionized water again. What I'm going to use now is this sample. There's still river water in here. So what I'm going to do is take 11 mLs out of here, transfer it to here. Once I get this one made, I'll do that yet another time. So I can go ahead and add this. You always want to add this first, remember. And we make these concentrations the way we do. We start with the strongest one and go to the weakest one. Just for ease of procedure. It's just easier to cut it down in steps than go the reverse way. When you actually filter your water, you're going to start with the weakest one. Thank you again. So I got 10. Remember, I need 11, so I'm going to draw some back out of here. Now be careful with this because you have to make sure this stays at its 100 amount. Going from 6 to 7, adding 1 more ml. The rest goes back here. So what I've still got here is 100 mLs of water, and I'm about to have another dilution made. So the one I'm mixing now is only 10% as strong as the first one, but there's still enough bacteria in that water to show us some results. One more time. Now the last time, since this is our last one, this is 0.1% strength. I don't need to make a further one, so I'm just going to have 90 mLs of deionized water and 10 mLs from this sample. So here's my 10. Thank you. Now remember, while you're doing this, two of you are doing this, probably a two-person job. The other two of you are going to be doing something else we'll show you in a minute. But what we don't want happening is 3 people sitting in the bleachers and one person, you know, sitting here doing all the work.
Stop.
Thank you.
Oh, you got to return that.
Oh, yeah. Thank you. Good thing I had somebody checking up on me here. All right. Thank you very much. You've also got to be careful since you're working in a sterile work area. You know, your classmates might be interviewing you or talking to you, but, you know, keep them the heck out of here. Don't let them come over here and, you know, contaminate the table. All right, so I've got 3 concentrations of river water. Any good science experiment has a control as well, so Mr. Piskel once again is going to town on that deionized water bottle. So we're now going to have 4 samples, 1 control, and then 3 different strengths of river water. And what we're going to do now is we're going to show you what your classmates would be doing at the same time you're doing this. And then we'll show you how to filter these and get the bacteria on the filter paper, and then we'll incubate it.